Today's lesson, solving rational equations. We've actually solved some rational equations along the way, and the methods we use there we'll pass right along here. This lesson isn't too crazy. Quick example to show some rational equations we've already solved. Say you've got x minus 2 over x minus 3 equals 0. If we wanted to solve that equation, the big holdup is the denominator of x minus 3. So we bring that over to the right-hand side, and if it's dividing by x minus 3 on the left side, it's going to be multiplying by x minus 3 on the right. So when I bring that over by multiplying both sides by x minus 3, there's a 0 waiting for it there, and I just have to deal with the numerator. It's a statement I made before about rational functions, is that if you want to know whether they're equal to 0, you just have to find out where the numerator is equal to 0. So if the right-hand side is equal to 0, we've got a nice, easy situation. We just have to worry about the numerator. And here the numerator is x minus 2, and that comes out to 0. Now, notice something else that happened here is that we stated the restrictions. And the restrictions are going to be important because when we're solving these equations, when we get back, I wanted to finish it off first so you can see that x equals 2. When you finish there, then what you've got to do is look and see if you got restricted in there. And so when I go to my pen here, you see, the restriction said x can't equal 3. Well, we came out with x equals 2, so we don't care about the restriction. So when you're solving equations, the restrictions take on a new meaning, is that you have to check the restriction at the end to make sure that you didn't accidentally break the restriction. So in this particular case, the restriction was x can't equal 3. I found out that x equals 2, and I don't have a restriction problem. So the answer to the question, the answer to the equation is x equals 2. It really should seem similar to finding x-intercepts in this particular example. Be sure to check that the solution is not a restricted value. It doesn't happen very often, but every once in a while it will. Oh, it says you try, and there's 3 examples here. It says, solve the following rational equations. It gives us 2 examples to work with, and then a word problem, which is a really devastating word problem. So we'll come back to that, and just to get some room to write, I'm going to take these equations they want me to solve over to Microsoft Word. A little easier for me to write in there. And the first equation was x plus 3 over x minus 4 equals x minus 1 over x plus 2. And maybe my words echo in your head is that I only have to worry about the numerators, but that was only true when one side was equal to 0. When one side of the equation is equal to 0, all we have to worry about is the numerator of our rational function. In this particular case, the right-hand side isn't equal to 0, and so I've got to do some moving around here first. And the moving around I'm going to do is actually a trick that comes from grade 10 academic math, is this thing called cross-multiply. In the examples, there's some completed examples on the website you should check out. It shows all the steps of where cross-multiply comes from. But essentially what happens is, on the left-hand side of this equation, the denominator is x minus 4, which means it's dividing by x minus 4. I'm going to move that over and make it multiply by x minus 4 on the right side. But at the same time, on the right side, the denominator is x plus 2. So I'm dividing the right side by x plus 2. So I'm going to bring that over to the left side and make it multiply by x plus 2. And why it's called cross-multiply is that all happens at once. The x plus 2 comes over here and gets multiplied by the x plus 3. And the x minus 1 gets joined by the x minus 4 from that side. So the 2 denominators come over and become multiply on each side. Well, what happens next? Some FOIL. I get x squared plus 3x plus 2x plus 6. The right side I get x squared minus 4x minus 1x plus 4. And here's a big idea of solving quadratics. In fact, in solving any equation above degree 1, is that it's not the x value we're trying to isolate. We're trying to isolate a 0 on the right-hand side. So when we have x squareds in there, we want to isolate 0 on the right-hand side. When we have just x's, we're just trying to isolate x. That's the grade 9 method. Well, you've seen all this in previous chapters, but the idea being, I'm going to do a little simplification here. And then I'm going to bring all those terms from the right-hand side over to the all the terms from the right-hand side over to the left-hand side. And they all change operations when they come over. They all change signs, sort of. And collect like terms, and look what happens here. In that moment, things tidy up dramatically. They don't have to. It might not tidy up, and you might be stuck with factoring or the quadratic formula, something like that, and solving equations will look like it did in chapter 3 and 4. In this particular case, the quadratic became a linear function, and linear functions are solved by isolating x. And I get x equals negative 1/5. Now, if you're right with me, you'll notice I've skipped a step, which I think should be most people's first step. After you've seen one solution like this, you go, oh, I better check that right at the start. So right at the start is what you were sort of trained to do in grade 11, was state these restrictions. If x can't equal 4 or x can't equal negative 2, I can't be dividing by 0, so those two denominators can't come out to be 0. And then at the end, I check those. X equal to negative 1/5, which was the answer I got down here. Not very neatly, by the way. Let's just tidy that up a little bit. Negative 1/5. And then I double check to see that it's not one of my restrictions. And it's not. So it very rarely happens, but you got to watch out for it. Okay, so what I want to say about that example is that when there's not 0 on the right-hand side, you're going to have to do some algebraic manipulation. And often it becomes multiplying, doing cross multiply like that. But it doesn't have to be. There's another method of doing this question called common denominator. And it's a bit more difficult. But it has some advantages. So I encourage you to do some of this homework and then look back at the common denominator solution that's on the website. This example that I've done right here is done on the website on a completed teacher note. But there's also a common denominator solution. Your immediate reaction might be, well, if it's more difficult, why do I want to use it? You need it for tomorrow's lesson, for the next lesson. You know, these questions can be done this way, but there's a type of question that tomorrow has to be done another way, and it's the common denominator way. And so you better check it out. So you may as well check it out. So do some of the homework like this to make sure you got it down pat, because you can do equations like this, no problem. And then check out that other method just so you understand it, so you're ready for the next lesson. Okay, that was the first one. The second one was a slightly simpler equation that's so easy, it's difficult. I've learned my lesson here. I'm going to state my restriction right off the hop. X can't equal negative 7, so I know by the end of the question I got to make sure I can't state that the answer is negative 7 if that's what it comes out to be, because x can't equal negative 7. And so in this question, and we saw one similar to this in the other lesson, but I want to get rid of dividing by x plus 7, so I move it over to here and make it 0 times the x plus 7. Well, 0 times anything is 0, and I get 5 equals 0, which seems ridiculous. Put a couple exclamation marks there going, seems ridiculous. And all that means is there's no way for 5 over x plus 7 to come out to be 0. There's no solutions here. Okay, so be prepared for that as well. It's possible to get no solutions here. It means that the function you're talking about never does equal 0. In this case, the function has a horizontal asymptote at 0 and never crosses it. It approaches it but never crosses it. Not that you couldn't. You can cross a horizontal asymptote. This one doesn't. Okay, question 2. This is the one I said was very scary. Let's read it over here. What do we got? Vizzini bought a case of Dark Side of the Moon t-shirts for $450. He kept 2 t-shirts for himself and sold the rest for $560, making a profit of $10 on each t-shirt. How many t-shirts were in the case? This is the type of question that drives people nuts, because there doesn't seem to be any good way to start this thing, and it just seems to come out of nowhere. So I want to walk you through it and sort of prepare you for this type of word problem and just talk about a few things that we need to know in this case. One is, I really like starting questions like this and reading them a different way. When you read a question like this, don't get hung up in the details, don't let your brain explode in the details. Just really focus on what's the unknown. What am I trying to find? Because it's a good way to start the questions. It says, Vizzini bought a case of Dark Side of the Moon t-shirts. Don't care. He kept 2 t-shirts for himself and sold the rest for whatever, $5.60, making a profit of $10 in each t-shirt, whatever. How many t-shirts were in the case? Okay, good. I've got my unknown. How many t-shirts were in the case? I go back. Oh, oops, not there. This one. How many t-shirts were in the case? Let X be the number of t-shirts in the case. Okay. It seems like nothing, but it's an excellent start to the question. Don't let yourself be fooled that this is not a great start to the question, because it certainly is. Now, then I need an equation for the situation that I can solve. Just buying myself some room here. There, that'll give me that extra page. Okay, let X be the number of t-shirts in the case. There we go. Now, I need an equation for the situation. I want to talk about equations in general. This equation talks about profit. So I want to talk about some equations, hopefully, that you understand. One is that this is maybe an equation that some people would argue is the most important equation in the world, is that profit equals revenue minus cost. And what we mean by that is the profit you make on something is equal to how much money you bring in minus how much money you paid out. That goes back to as simple a situation as running a lemonade stand at your house. Let's say you run a lemonade stand, and at the end of the day, you've got $100 in your jar from selling lemonade. You say, oh, I made $100. Well, that depends. If you have no costs, you made $100, but maybe you had to pay for the lemonade that you bought, which was $20. So you only really made a profit of $80 after you paid your costs. So there's 3 important quantities here. How much did I make? How much was I given? And how much did I have to pay out? And that's what profit, revenue, and cost are. Now, this question here doesn't talk about, it talks about something else. It says profit per shirt and revenue per shirt. So I'm just going to change that equation ever so slightly and say, in this case, profit per shirt equals revenue per shirt minus cost per shirt, because it was all talking about how much profit that he made per shirt. Okay, well, that actually is a great start to handling this question, because they told us some of these things. When you go back to the statement, it says, Vizzini bought a case of Dark Side of the Moon t-shirts for $4.50. He kept 2 t-shirts for himself and sold the rest for $5.60, making a profit of $10 on each t-shirt. Okay, very helpful. His profit per t-shirt was $10. Great start. Now let's talk about the revenue per t-shirt. And to talk about the revenue, I'm actually going to skip to the next one, because the cost per shirt is a little easier to understand. The cost per t-shirt. Let's talk about the cost per t-shirt. How much did he pay for these t-shirts? He paid $4.50. It says that right in the question, $450, right there. Vizzini bought a case of Dark Side of the Moon t-shirts for $450. So he paid $450 for all the t-shirts. I'm going to put that over here, $450. But how many t-shirts did he buy? That wasn't the cost for each t-shirt. That was the cost for all the t-shirts. How many t-shirts were in the case he bought? And I phrased that, tried to be clever there to phrase that just like the statement we made up here. It was X t-shirts he bought. So the cost per shirt is $4.50 divided by the number of t-shirts he bought, which we don't know. Now we switch over to revenue per t-shirt. Revenue per t-shirt, it says he sold the rest for $5.60. So his revenue per t-shirt was $5.60. He sold them for $5.60. Divided by however many t-shirts he sold. And this is the really tricky part of the question. How many t-shirts did he sell? Well, he bought X t-shirts, but he didn't sell X t-shirts. Take a look at the question. There's a little trick here. Let me read it again. Vizzini bought a case of, well, in our cases now, We know how many t-shirts he bought. He bought X t-shirts. So I'm going to rephrase the question. Fazzini bought a case of Dark Side of the Moon. Sorry, he bought a case of X Dark Side of the Moon t-shirts for $4.50. He kept 2 t-shirts for himself and sold the rest for $5.60. He kept 2 t-shirts for himself. So the number of shirts he sold wasn't X. It was X minus 2. Listen, folks, I don't think for a minute that's simple. And I don't think for a minute that's easy. But hopefully I've walked you through that type of question. So when you see those types of questions in the homework, you've got an approach for them. You go back and watch the video and get used to that type of word problem and other ones close to it. Well, now, at least it's algebra. Switch over to algebra from here. And I'm going to show you an incredibly good trick for solving these type of rational equations. I could, whoops, I forgot my subtract sign there. I could get common denominator. I could try and do cross multiply after that and so on. But there's a wonderful trick that there's a great chance you saw in grade 9. And the trick was, when you see fractions in an equation, multiply through by the common denominator. And it's such a good move here. And I'm going to try and use another color here. I'm going to multiply this whole thing. And this is the way a lot of teachers teach it in grade 9, is they just out here go, okay, I'm going to multiply by the common denominator. I'm going to multiply this whole thing by x and x minus 2. Now watch this carefully and slowly, because this does a miraculous thing. When I multiply x and x minus 2 times that 10, oh, it doesn't want to show that there, times this 10 here, I get 10 bracket x minus 2, which is very upsetting, because you say, well, you just had a 10 there, and now it's 10x bracket x minus 2. You said you were going to simplify things, and that certainly doesn't simplify things. But check this out. When you multiply x and x minus 2 by this 560, don't jump ahead here. Really look at what you got there. You're multiplying x and x minus 2 by 560, and then you're dividing by x minus 2. Those two x minus 2's cancel. Stare at that for a while to see that when you multiply those terms, you see the x minus 2 in the numerator, or the x minus 2 that you're multiplying by, and the x minus 2 you're dividing by. After that's all done, they're gone, and all you got left is 560 and x. It's such a great move. Because now I don't have fractions in this thing. I didn't have to do common denominator. I didn't have to do anything like that. And now, x and x minus 2 times this one. Stare at that for a minute. We're multiplying by x and x minus 2, and then we're dividing by x in that term. This time the x's cancel. And you're only left with the x minus 2. I don't know if that looks better to you. I don't know if that equation looks better to you. Maybe it doesn't, but it is way better because we don't have denominators anymore. We didn't have to do common denominator. We didn't have to worry about fractions at all by multiplying through by the common denominator. So I'm going to give that the red highlighting right there. That is like a gold move because it clears out the fractions in the whole situation. And I'm going to do the rest of it fairly quick. Not because I'm trying to rush the lesson, but because I want to show you that the rest of it, after you do that trick, should be stuff that's pretty straightforward for you at this level. Multiply out the brackets over here. Multiply out the brackets over here. Bring everything to one side. Because we want to isolate that 0 because this is a degree 2 equation. And then I collect up these like terms. Let's see, minus 130x, minus 900. And always look for the common factor. Look at the beautiful common factor in this one. 10x squared minus 13x minus 90. And you could quadratic formula this thing. That's a legitimate way to do it. But this thing factors. Two things that multiply to 90, but add to negative 13. Let's see, 1 and 90, no, that doesn't work. 2 and 45, no, that doesn't work. 3 and 30, no, that doesn't work. 4 doesn't divide into 90. 5 and 18. Okay, x plus 5, x minus 18. So therefore, x equals negative 5, or x equals 18. And hopefully now you're going to get used to checking these answers all the time and seeing what's legitimate. Back here, some restrictions in orange. after I built this equation. X can't equal 0, x can't equal 2, which is a little hint of where restrictions come from. Why can't x equal 0 and why can't x equals 2? Well, first of all, he sold t-shirts and made money. So there's no way he sold 0 t-shirts. So the number of t-shirts can't be 0. Also, he kept 2 and sold t-shirts. So it can't be that he got 2 t-shirts and sold them, because that doesn't make any sense. So there is some sense to the algebra here. There is something that makes sense about all this, about these restrictions in the context of the problem. So all these restrictions the whole time might have been like, wow, where do these restrictions come from? Why do we care? When we get problems in context, you'll see the restrictions will automatically make sense in the context of the question. So x can't equal 0 and x can't equal 2. That's good. I didn't get either of those answers. You usually won't. There's another problem here. We can't have negative 5 t-shirts. That can't be a thing. That mathematically works out for the equation I built, but it doesn't legitimately solve the question. But I do have this one. Therefore, he bought 18 t-shirts. That problem might seem ridiculous. It is ridiculous. So why do we do it? Well, we're getting you ready for chemistry, engineering, science, physics, computer science, biology, any of these fields, and we don't have the background in those fields just yet to have the equations from there. So we're making up some semi-ridiculous situations that'll introduce you to these type of equations so you can learn to solve them and get ready for whatever field you're heading off into. That question is big and scary. I totally get it. The good news is it's very repetitive. There's a few of them like that in the homework. And so that's a good hint as to a type of word problem we might use on an assignment or a test. So really work on that question and really try to get a feel for it and watch that video again when you need to. Okay, one thing I want to mention before this is over is these 2 basic methods I showed to solving rational equations. One is if it's a single fraction on each side. So if this is all you write down in your on the top of your homework before you start, if it's a single fraction on each side, you can cross multiply and you're in great shape. If it ends up that there's fractions all over the place like this one, multiply through by that common denominator right there. And that'll clear out the fractions. Get ridiculous answers, check your algebra. Okay? That's all.